Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you.
Hey folks, I have only two questions for you. One, are you trying to find a job in IT? And second, are you trying to gain some core knowledge of IT? If your answer is yes, then you have come to the right place. This is the course for you. Now, no matter which IT field you want to pick, maybe you want to become a Linux administrator, Windows, a VMware, networking, storage, security, programmer, developer, whichever field you pick, you have to know the basic, the core, the fundamentals of IT, such as what is a CPU, how it functions, what is a core, what is a socket, what is 32-bit or 64-bit architecture, what is OSI network layer, what are the difference between TCP/IP and OSI, what is an SQL, what is a RAID, what are the different type of storages that are out there. These are the basic things you have to know before you step into IT. My name is Imran Afzal, and I've been in IT since 2001. I've been working for Fortune 500 companies in New York City. I have bachelor's degree in computer information systems from Baruch College, which is the City University of New York. I also have an MBA degree from New York Institute of Technology. I have been teaching since 2010, and I have helped so many of my students land the dream job that they have been looking for years. So, are you ready to take this journey with me? Together, I could teach you everything you need to know about the fundamentals, the core about IT.
Hello, beautiful people. Let's spend a few minutes and go over our course syllabus and understand what exactly is included in this course. I have broken down this course in 14 different sections. In section 1, we'll talk about the introduction to IT, that is the meaning, the importance, and we'll talk about computer language, 0 and 1. We all talk different languages in humans, but we in computers, there are no languages like English or Chinese. We'll talk 0 and 1. Then every section will have quizzes and handouts. Moving on to section 2, which is the computer components, we will slightly cover every single component of computers, such as hardware, software, operating systems, application, networking, database, storage, virtualization and cloud, security, quiz, handouts, and homework. Then starting with section 3, we are actually going to pick each one of these components and we're going to drill down. So starting with section 3, hardware, we'll talk about different type of computers. We'll install RAM and I will show you actually when I'll open up the computer, I'll show you where RAM is located and how you can replace it. Similarly, we'll do for CPU and its core and sockets. We'll install the CPU, then we'll talk about the 32 and 64-bit processing architecture, disks, hard disk, motherboard, other internal parts of computer, external components, hardware manufacturers, computer comparison with our human body, and then quiz handouts and homework. Moving on to section 4, which we'll talk about everything about the operating system, the types, the functions, the buildings, CLI, and GUI operating system, computer boot process, and then we'll end with quiz handouts. Then moving to section 5, which will be the software and different type of software, system software, application software, freeware and shareware, open source software, BIOS and accessing the BIOS, program and services. So everything that you talk about, there are so many things you probably heard about software. Hey, is this a free software? We'll talk everything in this section. Then moving on to section 6, which is about networking, how computers communicate with each other, IP address, TCP/IP, gateway, subnet, MAC address, OSI layer. I'm sure you have heard of it, but I will take some time and explain you how it works and how important it is in computer networking. We'll talk about OSI and TCP/IP protocols and ports, types of network devices, how internet works. Moving on to section 7, which will be everything about database, RDBMS, which is a relational database management systems. What is SQL? Top 5 RDBMS. Then section 8 comes the storage, computer storage introduction, how storage is calculated, types of storage, difference between RAM, swap, virtual memory, and cache, hard disk, SSD, solid state drive, RAID, top data storage vendors. Then moving to section 9, virtualization cloud, how virtualization works, basic virtualization terms, benefits, difference between cloud and virtualization, the technologies, VMware Workstation Player, Oracle VirtualBox installation, setting up virtual machines. We'll talk about how we could do the installation. We will actually do as a lab setup, and I will make you go through setting up these virtualization software and setting up virtual machine. Then coming down to security section 10, another most important component of IT. We'll talk about different threats, breach, how we could secure operating systems, physical server applications, and so on. Then section 11 is about Windows operating system. You are getting into IT, you should know somewhat of Windows. We're not going to cover everything about Windows, of course, but a very few important topics of Windows, such as file systems, system resources, server managers, role and feature, Active Directory, and so on. Same thing we'll do with Linux. We will install Linux together and we will access the Linux, how we could access file system, directory listing, system utility, and so on. And then the troubleshooting concept. So this is very important for anyone who is getting into IT in terms of how you could troubleshoot. And the last one is additional resources, which will cover some of the bonus lectures that I will add it to the end. So good luck, and I'll see you in the next lecture. Hello, beautiful people. Let's spend a few minutes and go over our course syllabus and understand what exactly is included in this course. I have broken down this course in 15 different sections. In section 1, we'll talk about the introduction to IT. That is the meaning, the importance, and we'll talk about computer language, 0 and 1. We all talk different languages in humans, but we in computers, there are no languages like English or Chinese. We'll talk 0 and 1. Then every section will have quizzes and handouts. Moving on to section 2, which is the computer components. We will slightly cover every single component of computer, such as hardware, software, operating systems, application, networking, database, storage, virtualization and cloud, security, quiz handouts, and homework. Then starting with section 3, we are actually going to pick each one of these components and we're going to drill down. So starting with section 3, hardware, we'll talk about different type of computers. We'll install RAM and I will show you actually when I'll open up the computer, I'll show you where RAM is located and how you can replace it. Similarly, we'll do for CPU and its core and sockets. We'll install the CPU, then we'll talk about the 32 and 64-bit processing architecture, disks, hard disk, motherboard, other internal parts of computer, external components, hardware manufacturers, computer comparison with our human body, and then quiz handouts and homework. Moving on to section 4, which we'll talk about everything about the operating system, the types, the functions, the buildings, CLI, and GUI operating system, computer boot process, and then we'll end with quiz handouts. Then moving to section 5, which will be the software and different type of software, system software, application software, freeware and shareware, open source software, BIOS and accessing the BIOS, program and services. So everything that you talk about, there are so many things you probably heard about software. Hey, is this a free software? We'll talk everything in this section. Then moving on to section 6, which is about networking, how computers communicate with each other, IP address, TCP/IP, gateway, subnet, MAC address, OSI layer. I'm sure you have heard of it, but I will take some time and explain you how it works and how important it is in computer networking. We'll talk about OSI and TCP/IP protocols and ports, types of network devices, how internet works. Moving on to section 7, which will be everything about database, RDBMS, which is a relational database management systems. What is SQL? Top 5 RDBMS. Then section 8 comes the storage, computer storage introduction, how storage is calculated, types of storage, difference between RAM, swap, virtual memory, and cache, hard disk, SSD, solid state drive, RAID, top data storage vendors. Then moving to section 9, virtualization cloud, how virtualization works, basic virtualization terms, benefits, difference between cloud and virtualization, the technologies, VMware Workstation Player, Oracle VirtualBox installation, setting up virtual machines. We'll talk about how we could do the installation. We will actually do as a lab setup, and I will make you go through setting up these virtualization software and setting up virtual machine. Then coming down to security section 10, another most important component of IT. We'll talk about different threats, breach, how we could secure operating systems, physical server applications, and so on. Then section 11 is about Windows operating system. You are getting into IT, you should know somewhat of Windows. We're not going to cover everything about Windows, of course, but a very few important topics of Windows, such as file systems, system resources, server managers, role and feature, Active Directory, and so on. Same thing we'll do with Linux. We will install Linux together and we will access the Linux, how we could access file system, directory listing, system utility, and so on. And then the troubleshooting concept. So this is very important for anyone who is getting into IT in terms of how you could troubleshoot. In section 14, we'll talk about the introduction to AI and ChatGPT, which is everyone is talking about. We'll start with what is artificial intelligence, its history, the feature it has to offer. We'll get into AI versus robots, the benefits of AI, and the limitation of AI. Then the last section is about introduction to DevOps. A lot of IT people wants to get into DevOps, so I wanted to definitely cover this section. And in this section, we are going over what is DevOps, its history, what are the challenges of pre-DevOps, team collaborations, benefits of DevOps, and the importance of DevOps. Now you decide yourself, does this course has so much to offer that you could learn so much about IT and then you could start anywhere you want to go in IT. Good luck to you. Hey, beautiful folks. Before we get into the details of IT, let's take a few moments and understand the true meaning and real meaning of IT. We all know IT stands for information technology, but what does it really mean? It's a transfer of information from one person to another, from one location to another, through the means of technology. Now, to understand it better, let's ask a few questions. Some common questions are, what is that information that we're transferring? That information consists of files, letters, applications, folders, or PDF documents that you have. Your images, the pictures you probably took when you were vacationing, you want to share it with your friends. Same thing with videos. You made some videos or certain videos that you see, you're transferring that. Music, instant messages. You use Facebook or WhatsApp or any kind of instant messages to share it with other people. Emails. So if you have personal email or corporate email account, you send emails to your boss or your coworkers. So you are sharing that information. Now, where are you sharing it to or with whom? As I said before, from person to person, from company to company, from location to location, which means from one city to another city, from one country to another country. You share all that information through technology. When are you sharing? 24/7, 7 days a week, and 365 days a year. Yes, there is no business hour like a post office. You have to go in and you have to wait for the post office to open up so you could transfer your information. This is all happening in real time and at all times. Now, why are we sharing that information? That's a very good question. The reason we share that information, so you could have that information and you could make a decision, you could solve a problem, you could do some planning around it, and that could save you some time and make improvement to your system, and finally you could save some money. So every company, every person, when they have some numbers, some information, they crunch, they massage those numbers, and so they could make a right decision based on the historical facts. Everything is about information. Now, we all know all these four things. Now, how are we sharing that information? That's where comes the technology. We need IT components to make that what, where, when, and why happen. And those IT components that you need to transfer information, those are like computers, operating systems, applications, and network security, database storage. You need all of these IT components and many more, by the way, to transfer information from one person to another. So, anyway, I hope now you understand completely that the real meaning of information technology. I'll see you in the next lecture. Hey, folks, let's take a look at the importance of learning information technology. It is, of course, very important for ones to learn the basics of IT in everyday life. So, if you want to buy a computer, or if you have a computer and you need to upgrade that computer, you need to know what's inside of it. What is a memory? What is a CPU? What is the processing speed? All that information you do need to buy a laptop in a smart way. Same thing if you wanted to buy a cell phone, you need to go out there, you need to know how much disk space it has, how much memory, CPU, the processing. For some people, the camera resolution matters. For some people, the applications, how fast it loads. For some people, how fast the internet is. There are many things. So all of those things that you see inside of your phone is actually a basic knowledge of information technology. Then moving on, every job requirement. Yes. So regardless if you are in IT or not, let's say if you are in a medical profession or you're a doctor, in a lot of doctor facilities or hospitals, there are these bigger scanning machines like MRI, the CT scans, and many other those radiology big machines that actually takes the scan of a human being and prints the report. You read the report, you need to understand how to operate those machines. Maybe there are some technicians that actually qualifies or have the major information or technical information on that machines. But you being as a doctor, you need to know what's the really functionality of that machine, how it operates, very basic knowledge. Same thing if you're in accounting. In accounting, there are so many applications that people use. Those applications run on a computer. What happens if you are dealing with multi-million dollar balance sheets and suddenly your computer is running slow or crashes? You need to know some basic understanding of IT, right? Moving on, career path. Yes, that's one of the biggest one. If you are getting out of the college, you wanted to get into IT, then of course there is no such thing as basic knowledge of IT. You need to know everything inside out of an IT, and that's what this course is going to provide you, everything that you should know about IT, even for the people who are actually into a different field and they want to switch to a different path. This is the best career path for them. Then, business startup. So, if you are starting a business for the first time, you do need to know your point of sale systems, what applications you need to run, how much resources you need. If you are putting up the HR applications, the accounting applications, if you are doing some kind of timesheet, you need all those applications. And of course, either you could do those applications outsource to another cloud company or you do it local. But again, all that cloud, local, hosting, all these keywords, you do need to understand. And the only way to understand those keywords if you have a better understanding of IT. All right, so the next one we have is the side hustle. Yes, so when you learn IT, you will also learn different ways to make money as well, because IT is the field that provides you a lot more opportunities as a part-time aside from having a full-time job. A lot of people are looking for freelancers, people who could help out short term, or people could work on a little different projects. You could find or you could provide your services to different websites that are out there. Some of the examples are like Upwork.com or Fiverr.com and many others, I'm sure. So when you are in the IT field or when you start learning IT and you refine your skills in IT on a specific field, you can earn as a passive income through these different websites that I mentioned. Okay, guys, so now we have a better understanding what is information technology. Now take a look at what a computer is. Of course, we need a computer for information technology to work. So let's take a basic definition of computer. A computer is a machine that can be instructed to carry out sequence of arithmetic or logical operation automatically via computer programming. Modern computers have the ability to follow a generalized set of operations called programs. These programs enable computers to perform an extremely wide range of tasks. Now, this definition, I got it right out of the Wikipedia. Another definition of a computer is an electronic machine that manipulates information or data. So that information can be stored, retrieved, and processed the data. So you could save it, and anytime you need to pull that information, it can be retrieved from the disk. You could change that, process it, manipulate it, that information. That's when you need the computer. Now, let's take a look at my definition of a computer that will help you understand what a really computer is. For me, a computer is a device or electronic device that moves information from one person to another or from one location to another when a computer is connected through the network or through other computers. That's what really computer is. So another way or another definition would be a computer is used to run desired applications that are needed for personal and professional reasons. Now, ask yourself that the moment you turn on the computer, what do you expect out of that? Of course, it starts up, it starts the operating system that runs on a computer, and then what happens? You go to a certain application. You start Microsoft Word, Microsoft Excel, or you go to your games, or you go to the web browser, you start those applications, right? Without those applications, do you think you really need a computer? No. So the main purpose of a computer is to run those applications, and that those applications are the ones that makes life easier. Those applications puts things on an autopilot for you. That's why we need a computer. Hey folks, we all know we speak different languages in the world, but what is the language for a computer? Now you coming into an IT, you should really know how computer reads your input from the keyboard, what language your computer speaks, and that is simple 0 and 1. So computer does not know any human language. So they don't know English, French, Chinese, or any language for that matter. It only understands zeros and ones. Computer language, that 0 and 1 language, it's called binary. Computer stores all characters as numbers on hard disk because computer don't know what is hello or how are you is. Computer converts that into these numbers, zeros and ones, and that's how it stores that into the hard disk. The process of converting that data into binary code is called encoding. Now, to better understand, let's visualize it. Now, where is that 0 and 1 comes from? Your computer runs on electricity. If you unplug the power or if your battery runs out of your laptop, your computer will shut down, right? So computer to transmits the data, to save that data, it actually uses 0 and 1, and that 0 and 1 concept came from the the electricity. 0 means off, and 1 means on. So this I or one that you probably see on your switch. If you go to your switch right now, or if you have an older switch, probably newer switch don't have those 0 and 1 anymore. But if you find one in your house, you're gonna look at it closely and you're gonna see one on top or at the bottom, depends which country you are in. So the one means that turn on. Zero means to turn it off. So we all know that how that switch works. So similarly, the computer sends or saves the data on the computer or transfer the data through these zeros and ones. Now, moving on, let's put it in an example of how it could translate a word into zeros and ones. There is a chart that's called a binary chord chart. That chart, each letter, that English letter that we have, has a number or a binary number associated with it. So like A has 1000001, B has 1000010, and so on. So now let's say if you type it in hello on your keyboard. Now, how your operating system or your computer is going to translate that into its processor or memory that, hey, this hello means these digits, so process it. So the first thing it will do is will take the first character, which is H. And by looking at the chart, you will see the H translates to 1001000, meaning on, on, off, off. Same thing, E translate to 1000101. L, L, and O 1001111. So that's like a cheat sheet the computer has, and computer knows that when the letter H comes in or E comes in, I'm gonna have to translate into binary. And again, the binary is on and off. So when the computer puts all these numbers together, it actually sends these signals as on off on off on off on off, and that's how it actually translates or move the data from one computer to another or from your keyboard to the hard disk. Okay, moving forward, let's talk about ASCII. Now you probably have heard of ASCII. What is ASCII? ASCII, first of all, stands for, or it is pronounced as ASCII, and it stands for American Standard Code for Information Inter-Exchange. It allocates a number to each letter, digit, and symbol. It is like a middleman or a translator between your keyboard characters and the binary. So every character that you see on your keyboard or US keyboard, that character has a number associated with it. That number was assigned by American Standard Code or ASCII people. So they were sitting there, they said, you know what? There's so many computers that we are building in back in 1960s, and they communicate with different ways. We need to come up with a standard, and they came up with the standard. And now they said we will assign that number to each character, and then that number will be translated into binary. So let's look at this chart. You will see the columns, the decimal, the binary, the octal, hex, and ASCII. So we'll cover the hex in a second. But if you look at the H, in the H value in the table has an ASCII code of 72. So the computer assigns 72, and then the 72 gets translated into the binary, which is again, that's what computer understands, 01001000. Okay, so as the computer it grew over time. It was introduced in many different countries, many different languages. So there were so many characters that were introduced. As you can imagine, there's so many languages in the world. So they were the first time the computer was introduced. Of course, that was in English language in ABC. So they didn't think of it that they would have to come up with different ways to translate. So they came up with more ways, and that is hex. So if you are typing in Chinese, a Chinese character could be a number that is assigned to it, just like American Association assigned a number in ASCII. So they take hex, convert hex to, again, to binary. All right, guys, that's a lot of information, but the main point that I want you to understand or take away from this lecture is that computer only understands binary, and those binaries are 0 and 1. Hello and welcome back. In this video, we are going to talk about the application. Right from the image, you'll see that's the third layer of the image where the application runs on top of the operating system and users like us access those applications. So application is also one of the major components of computers. Application is a program or a combination of programs designed for users to perform certain or desired tasks. Take a look at the certain examples of applications so we'll have a better understanding. For example, Microsoft Word or Excel or PowerPoint or any of those Microsoft related applications are of huge examples of what applications are. Internet browser, if you're using Firefox, Google Chrome, or Microsoft Internet Explorer, those are all examples of application. If you're talking about the corporate world, in the corporate world, there are many bigger applications that manages your accounting or finances, and some of them like are ERP or SAP applications. For mobile users, like if you have a cell phone, you probably noticed that there are millions of applications that you could download from the Apple Store or Samsung Store. Those are those tiny ones that actually gets downloaded on your phone. It gets downloaded over your operating system, and those are called apps, short for applications. To further clarify the difference between the software and application, a software is anything that runs inside of a computer. So, a software can be an operating system because it is something that you cannot touch and it goes inside of your computer. A software can be an application that you create and with a combination of a program or multiple programs. So anything that is inside of your computer is a software, and a software is a very generic term that is used for all those coding programs that you create to run your computer. Hey folks, in this video we are going to talk about software and operating system. Operating system is a software as well, and software is anything that you cannot touch which runs inside of your computer, as compared to hardware is something you could feel or touch. Software is a written set of instructions that tell your computer what to do. Operating system, which is also a software, it runs on top of your hardware. Without the operating system, your hardware is just like a piece of brick or a piece of metal because it cannot function without an operating system. The operating system supports computer functions such as scheduling tasks, executing application, and controlling peripherals. So when you have the operating system, your operating system is actually controlling your devices. If you want to print something, through your application, let's say you have a Microsoft Word, you want to print your document, then that specific instruction goes to operating system and operating system sends it to the printer to print. Let's take a look at a few of the examples of our operating systems. Well, number one is Windows. Windows has the most market share in user environment. Then we have Mac. A lot of people use Mac as well. Then we have Linux. Linux is mostly used in the corporate world, and many times people use it as a command line. It also have a graphical user interface, which is called GUI, just like Windows. But again, most of the people use it without it, so it could function a lot faster. Another operating system you have Unix, which runs Solaris or AIX, and I'm sure there are many other operating systems that are out there. I don't want to list, but these are the main four operating systems that we could actually relate to. Then let's look at the example of mobile operating system that's running in your cell phone. Number one is iPhone, it runs iOS operating system. And the second one is Samsung, which runs Android operating system. Okay, so let's understand how our operating system works through this image. Here we have this image where the bottom layer you see it's a hardware. On top of it, we have our operating system running. Then on top of the operating system, we have our application programs running. And who are using those applications? You. You are the users who are actually accessing that application. Now, to make it more simpler, let's put down our hardware, which is our computer. On top of our computer, we have our operating system, and we take an example of our Windows operating system. When you start up your computer, the operating system starts up, and then you might need to use an application. And in this example, we picked Microsoft Excel. You probably need to use Microsoft Word, or you maybe need to use Firefox browser, or maybe other applications. And now, who are using these applications? That is you. That's how the actual sequence of operation works. And the operating system, if you could see, it's sitting in the middle between the application and hardware, taking the instruction from you and the applications and handing it over to the hardware.
Hello, everyone. Let's take a look at virtualization. What is virtualization? Before we get into explaining the concept of virtualization, let's take a look and understand of how physical system configuration works. So, in a regular world, as you could see, there is a physical server. A physical server could be like a Dell or HP or any of those manufacturers that build a physical server. On that physical server, what do you do when you get that physical server? You actually install an operating system on top of it. And that operating system could be Windows, could be Linux, or any of the operating system of your choice, right? Then what happens? You install the operating system, and then on top of that operating system, you run your applications. Those applications are, for example, Excel, Word in Windows world, in Linux world, you'll run like a DNS application, NTP application. In a regular applications, where rarely enterprise level application like ERP, SAP, PeopleSoft, all of those applications run on on that platform where the operating system is. So this is how you see an ideal or in a regular world how the layout works. Now, what's the problem with this? The problem with this is you have a physical server. The physical server has 16 gig of RAM and 4 CPU. And then you install operating system on top of it. Operating system only needs 4 gig of RAM and 2 CPU to run. And then you install an application on top of it, and that application only needed 2 gig of RAM and 1 CPU for that application. What happens then? Then you have 8 gig of RAM and 2 CPU that are wasted. Yes, resources are underutilized. That's why the virtualization was born. People thought, they sat down, they said, you know what? We have this physical server with so much resources. We only run one operating system and one application, and everything else is wasted. We gotta come up with a better solution. So now let's look at the virtualization. When virtualization came into being, then what happened? What happened was there's a physical server, same way, running Dell on HP, whichever whoever the manufacturer is. Then you install a virtualization layer on top of it. A virtualization layer from anywhere, like from VMware, from Oracle Virtualization. Then you install operating systems on it. So you could install two, three, four, how many operating system you can, depending on the resources that you have on the physical system. And then on top of those operating systems, you have the application individually run on each of that operating system. Now, what's the advantage? Let's look at the advantage. That's a physical server. Again, going back to 16 gig of memory and 4 CPU, you install a virtualization layer which takes up all your CPU memory and CPU. Perfect. Then that operating systems you have, then applications, each of that operating system application has 4 gig and 1 CPU. So each is each of that operating system has given all those resources, what happens then? All resources are fully utilized, not wasted. See how we could take the full advantage of all those resources? So again, one more thing. Remember those days when you have one physical server and one operating system, and then people came up with another idea of, you know what, split the disk in half and let's do dual boot. So one of the partition would run, let's say Linux, and one partition would run Windows. But the problem was with that is you could run only one operating system at a time. In virtualization, this is the beauty of the virtualization. You don't have to have one operating system run at one given time. You could run both or three or four operating systems at all times, all at the same time. That's why the virtualization is so important and so beneficial. Again, in layman's term, virtualization is something is really not real, but it is actually real. It is utilizing the system resources and sharing those system resources among all the operating system that runs on that physical server.
Hey folks, let's talk about the other IT components. We have already covered the three basic IT or computer components. Number one is the hardware, second one is the operating system, also referred to as a software, and the third one is the applications. So now let's say if you have a hardware, your laptop or your desktop, and it has a Windows operating system installed on it, and then you need to use Microsoft Word, and that's the application. You could work on it, save your documents on that computer, works fine. Now, what if you wanted to perform different functions? For example, one of the things that you wanted to do is you write up the application or you open a Microsoft Word, you type up an application or letter, and you want to send to your friend. That friend is using a different computer. So definitely that's where the other components come in. And that component is the networking. So you do need a network between computers to talk to other computers. So in this lecture, we are going to cover the networking piece. So the very first thing we have to see here is your computer. Your computer has again hardware, software, which is the operating system, and the applications that you need to perform certain function. Now, what if you wanted to send or communicate to another user that is on a different computer? Now, let's see if that computer is within the same location, then you could simply use a crossover cable to connect one computer to another and you could communicate. Now, what if you have multiple computers within the same location? Then what you could do is you could put in a switch, a small switch with the port requirement that you have depending on the computers you have. So you could connect your computer to that little switch or the Cat5 cable. Now, what is a Cat5 cable? That is something we will cover later on. And what is or how many little cables inside of a cat cable or cat6 cable, we'll cover that later. So anyway, for now you'll see you will connect to that switch, and from that switch you see these multiple ports, then you could attach those cables to these different computers, and that's how you could talk to these different computers. Now comes a question, what if there's a computer out on the internet or it's somewhere in another location or another part of the world and you want to talk to that computer? Then, of course, you need a modem or your ISP or your IP service provider. So, in my location, I have a service provider like Cablevision or Optimum or Fios. So, I'm sure whichever the part of the world you are, your internet provider is the provider who has provided you that modem that allows you to talk to outside world. So you connect your computer through the Cat5 cable again to that modem, and that modem is connected to the outside world, and that's how you communicate. But of course, if you need to communicate to the outside world, you need or your computer needs an IP address. IP address stands for Internet Protocol, and that is something we will cover in the later lectures. So that's pretty much another component of networking if you want two computers to talk to each other. I'll talk to you in the next lecture. Hey folks, as we are going through the IT components, let's not forget the storage. Storage is an extended component of IT and it does play a very vital role when it comes to storing data. So let's take a look at what storage is. And I'm sure you guys all know storage is a place in your computer where data is saved. We know that when you shut down your computer, all that data is saved. And when you turn the computer back on, you could retrieve that data from the disk. So it can be simple hard drive or solid state drive inside of a computer, depending on what kind of computer or what kind of hard drive that you purchase. Now, storage can be internal or external. Now, internal, it's inside of a computer. Now, external, that's where this becomes an important factor or important component in IT is to have external storage or array of storage that we will discuss in a few minutes. Now, in IT world, storage is another extended component, which is a collection of multiple redundant disks, also referred to as disk library or disk array, that is used mostly in corporate world to store large volume of data. Yes, so let's take an example to clarify it or simplify it a lot easier way. So in your home environment, you have your desktop or your laptop. And your laptop, you all know we have a disk inside of that laptop. That disk we create our data, we write our data, and then we save our data in that disk. Now, what happens if this disk dies or crashes or gets corrupted? Then, of course, you lose all your data from the disk. And I'm sure someone probably have experienced this kind of issue. I have actually experienced this issue too in the past, where I have saved all my data on that one disk and my computer crashed or disk crashed and I lost all the data. So, of course, that is something you could afford on the home. But when we are talking about the corporate environment, you do not afford to lose the data, the corporate level data. So, in corporate world, what they do is they actually buy these big shelves, big racks, and each rack they have multiple servers. They look like a server, but they have inside of these servers, they have actually arrays of disks. So each of that has disk, and many, many disks. And these disks are set up in a different RAID. What is a RAID? That is something we'll talk about later, definitely. But RAID, in simple words, is basically a redundancy of the disks. In case you lose one disk in this array, then you have other disk where you could get or retrieve your data. So this way, no matter what happens, or you lose one or two or three disks, or as many disks, depending on how you set it up, that corporate storage array, you will be able to retrieve that data. Now, that corporate storage can be accessed either through SAN or NAS. What are those terms? I will cover that in the later lecture. And I'm telling you, you do really need to know these things if you are getting into IT world. So, hope you understand what storage is on the corporate side, and we will cover much in detail in the later lecture. See you in the next lecture. Hey, folks, in this lecture, we are going to talk about IT security. Security is another extended component of IT. When we are talking about all these different components, please make sure we are not overlooking the security, which is also one of the most important aspect in IT. Let's take a look at the IT security definition. Security can be referred to as computer security, cybersecurity, or IT technology. Security is the protection of computer systems and network from information disclosure, theft of or damage to their hardware, software, electronic data, as well as from the disruption or misdirection of the services they provide. So basically, the security to secure your network or your environment, not only to protect your data, but also to protect your hardware where your data resides, the software that controls that data, and any of the services that runs on top of those software. All right, IT security prevents malicious threats and potential security breaches. that can have a huge impact on your organization. When you enter your internal company network, IT security helps ensure only authorized users can access and make changes to sensitive information that resides there. IT security works to ensure the confidentiality of your organization's data. So security can be applied at the following levels. It can be applied at the hardware, operating system, application, network, storage, database, and virtualization or cloud level. You do need security on all of these components, and security wraps around all these components. In the later lectures, when we get to the broader topics on the security, I will cover what are the security threats, how the security can be breached, what kind of security breach there are, and how are different ways to protect our computers. So stay tuned. I'll see you in the next lecture. Hey folks, in this section we are going to talk about the computer components, and the very first thing that comes in line when we are talking about computer components is the hardware. Now, what is hardware? Before we get into the hardware, we need to find out where they got the name ware, W-A-R-E, and attach it with the hard. So where actually anything, any merchandise, any products or any goods is a ware. Now, in from Wikipedia, computer hardware includes physical parts of a computer, such as the case. Case is also referred to as chassis, where everything is combined together in a case. Then central processing unit, which is inside of the computer, monitor, mouse, keyboard, computer data storage, could be hard disk or external disk, graphic card, sound card, speakers, and motherboard. All of these computer devices that are listed here are actually the hardware. Now, my definition to make it a lot simpler when someone asks you what is a computer hardware, then I would say anything you can touch in a computer world is a hardware. Anything you cannot touch is a software or a firmware. That's a very simple and straightforward definition. So if someone is going to ask you what kind of computer you have or what kind of hardware you have, right away you have to say, I am using Dell hardware. I'm using HP hardware or Sony or whoever the manufacturer is. That's what they wanted to know, the manufacturer of the hardware that you have. Hey everyone, in this lecture we are going to talk about the database. Database is another component of IT or computers. So, before we understand what database is, let's separate data from the base. So, what is a data? Well, data is a collection of facts such as numbers, words, measurements, observations, or just description of things. For example, your name, age, height, weight, etc. are some data related to you. A picture, image, file, PDF, etc. can also be considered as data. So now, what is the base? Base is something like a system, a foundation, or a hub, or a central location where all the data come together. So now, let's look at the database definition. A database is an organized and systematic collection of data, generally stored and accessed electronically from a computer system. Databases make data management a lot easier. Now comes the question is, data can be stored in a spreadsheet or a text document as well. So why we need a database? Well, that's a good question. Like we use spreadsheets or we have a text document, we could put our name, our age, and all that information into those documents. So why do we really need the database compared to those regular flat files? Well, database store information more efficiently. Databases can handle volumes of information that would be unmanageable in a spreadsheet. Spreadsheets have record limitations, whereas databases do not. Compared to databases, spreadsheet can require a large amount of hard drive space for data storage, whereas in databases it takes a lot less space on your storage. Also, in database, joining records is a lot easier than compared to text or spreadsheet. So let's say if you have a spreadsheet that only tells you the age and let's say some information, date of birth of a user. In another spreadsheet, there is names and the address of that user. So sometimes when you wanted to get all that data in one line or in one record, so combining those two spreadsheets, it's a lot harder than compared to running some join SQL statements to combine that record. So that's why we have database. The pulling the database or data out of database is a lot easier than compared to these simple files. Hello everyone. In this lecture we are going to talk about cloud. I'm sure you have heard this word cloud or IT cloud, cloud storage, cloud computing, cloud networking so many times, but maybe you're having a hard time understanding what really cloud means and what kind of services we could get from the cloud. In this lecture, I am going to make sure that I explain it to you, the cloud and its purpose and features in a very simple language. That is why recently cloud has become also an extended component of IT because a lot of companies are moving to cloud and therefore you need to understand the concept behind the cloud. All right, let's look at the definition of cloud first. Cloud computing is the on demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. Now, pay attention, without direct active management by the user. The term is generally used to describe data centers available to many users over the internet. Like there are data centers somewhere, but those data centers are available to you through the internet. Now, for those people who do not know what a data center is, a data center is where all the companies have their IT resources set up like in a shelf. All the computers are there, all their hardware gear, all their networking gear actually at a dedicated place. And that place is called data center. Now, let's go into details of defining how we could differentiate cloud from a regular data center. So, in our regular data center, for example, you work for a company ABC and you work for the IT department, and they have their data center. In their data center, of course, you have servers, and those server, the hardwares are actually managed by maybe the data center technicians or hardware technicians. Then on top of those servers, we have the operating systems running. Those operating systems are managed by system administrators in your company. And then there are applications running on that operating system like SAP, Oracle, or many other applications, depending on the requirement of your business. Of course, for those applications, you need the users who manage those applications. Then also in the same data centers, you have networking gear like firewalls or routers and switches. Now, if you most likely you do have them in your data centers. And then what do you need? You need people like network administrators or security administrators to manage those network devices or configure them for servers to communicate. Also, if you are running an application, I'm sure you want to put them on a storage that is redundant. So you need external storage attached to your server. And when you have the storage, what do you need? You need people like storage administrators to manage those storage arrays. Now, you see, you have to hire so many people in your IT department to actually get the application working for you. Now comes the cloud. The cloud companies came up with this concept of cloud. In the cloud, they have just the same data center like you have for your company, but you don't know where that data center is. Maybe it's somewhere in the world that you don't know, and you really don't need to know where that is. All you need the access. In that cloud technology companies who actually provide these cloud technologies, they already have in-house people, the administrators like storage, network, system administrators who actually manage the servers, the operating system, the network, the storage, and everything. They do everything for you. All you have to do is manage your application. You will access your application from those servers, and you will only need those users to manage those applications. That is the main difference, and in very simple words, the difference between the actual physical data centers that you have been working on with your company and anything on the cloud. And some of the examples I'll give you cloud is Azure Cloud, VMware Cloud, Amazon Cloud, one of the biggest one. We'll talk about clouds in a later lectures also. I will go through the difference between what are the difference between private cloud, public cloud, and some of the more details in the later lectures. But for now, I am sure you got a good gist of what a cloud is. And if someone is asking you to explain cloud, I'm sure you could give them the same example to explain what a cloud is. Hey, beautiful people, you are getting into IT. And it is very important for you to understand what are the different type of computers that are out there which you have to deal with. The very first computer is the first personal computer, PC. In 1981, IBM introduced its first personal computer and they called it as IBM PC. It is mostly for personal or individual use. It is best for internet surfing, running small application, and playing games. You can run Windows, Linux, or Mac as an operating system on your personal computers. So then we have desktops. Basically, desktop is the same as PC, but when you take that PC and you put it on top of your desk, it becomes a desktop. Yes, it's that simple. Then we have a laptop. Similarly, like desktop, you put it on desk. Laptops actually go on top of your lap. It is very convenient, very mobile. You could take the laptop with you wherever you go, and all you have to do is simply open up the laptop, put it on your lap, and perform any functions that you want a computer can offer. Once again, desktop and laptops, they are both personal computers. All right, then we have the workstations. A workstation is simply a desktop computer that has more powerful processor, additional memory, high-end graphic adapters, and an enhanced capability for performing high-end tasks. Nowadays, these workstations are actually come in a desktop kind of form or a laptop. Typically, big companies or corporate companies buy these workstations for their employees. All right, then we have notebooks. They are pretty much same as laptop. However, notebooks are generally manufactured to be sleeker, smaller computers with screen sizes of 15 inches or less, typically weighing less than 5 pounds and measuring less than 3 inches thick. Notebooks keep their supreme lightweight portability advantage over laptops. Now, if you are in a business of traveling where you have to travel a lot, then notebooks are the best suited fit for you so you don't have to carry heavyweight computers with you. All right. So next one is the mobile handheld or PDA computers. PDA stands for Personal Digital Assistant. Now, if you remember a few years ago, we had those personal or PDA computers that were used to schedule meetings or calls and very limited functionality. But now, these handheld devices is like computer on its own where you could actually connect to the internet and do or perform a lot of functions. A handheld computer is a portable computer that is small enough to be held in one's hand. Example of handheld computers are like smartphones, tablets, iPads, and many other devices. These computers are mostly used for very small applications. All right, moving on to the server. Server is the term that you will learn as soon as you get into the corporate world or you get a job in IT. Okay, let's understand what a server is. In computer world, there is a client and there is a server computer. A client computer, when it sends a request, server serves that request. So, as an example, like a web server, let's say if you go to www.google.com. So your computer in that case is a client and the computer, the Google computer where it's going to Connect, that's a server. Same thing if you're connecting your computer to a database, your computer is a client, the database where that database is running is a server. Servers usually have powerful processors, a lot of memory, and large hard drives. Typically, a server is racked horizontally on a computer shelf at a data center. Some of the big manufacturers of servers are like HP, Dell, Cisco, IBM, and few others. All right, then we have mainframes. Now, in the early days of computing, mainframes were huge computers that could fill in an entire room or even a whole floor. Yes, but as the computing power increased in computers, the mainframe became more like a server. So nowadays, since the real estate is very important, these servers, that mainframes that used to compute a large amount of computations, now that little computers or the servers that you have nowadays can perform the same functionality as the mainframe. All right, then we have a supercomputer. This type of computer usually costs hundreds of thousands or even millions of dollars. Although some microcomputers are single computer systems, just like one single server, most are composed of multi high performance computers working in parallel in a single system. So you could stack a few computers together or join a few servers together to perform one single function. That becomes like a supercomputer. So anyway, in this last slide, pay close attention definitely to the servers. Servers are the ones that you're going to be working with in corporate IT when you're troubleshooting or when you are managing these computers. Hello and welcome back. Do you guys know the computer was built based on the comparison of a human body? Yes, most of the things that we see in the computer are actually derived from our human functionality, the internal parts of our body. So let's take a quick look at what are the comparison or differences that we have in our body and to a computer. So right here we have a human body and this is a regular computer. The very first common organs that we have between a human body and a computer is a long-term memory. And in our head, long-term memory, and that is equal to a hard disk drive in a computer that retains a lot of information and it retains for a very long time. Then comes in the short-term memory in our head again, and in computers, we relate that to the RAM, which is a random access memory, and it keeps that information as long as the computer is running. Then the brain, our brain is the main uh, or critical part of our body that does a lot of computation, calculation, analysis. So same thing like that. The CPU is the brain of the computer. All right, moving on. The soul. Our body is basically dead or is nothing without a soul. The soul that we have inside. So as soon as that soul leaves our body, we are dead. So just like that, the operating system that is running on the computer or installed on a hard disk, that functions as a soul, which provides instructions to all the different part of our body. Then we have the backbone, which is the motherboard in our computer. And the function of our backbone is to provide a mean of transportation to communicate to the other components of our body or other body organs. Just like that, in the computers, the motherboard is used to communicate to all the components inside of the computer. And then there is a heart. Now, a lot of people think or take heart as a CPU, but it's not really a CPU. A heart is something that pumps the blood in your entire body. And in this case, in computer, you have to have that electric power in your computer so it could function and it could pass that electric or that power to other parts of the computer. All right, so then we have the body which en- encapsulates or encase our internal organs. And in computer, we call it chassis. And a chassis is the one that actually has all the computer components inside of it. Okay, moving on, and let's look at some of the senses that we have. Five senses of human, and we know it's a sight. I mean, we use our eyes for that sense. Then we have sound or hearing, and we use our ears. Then we have touch, and anytime we touch either from our feet, from our hands, or from any part from our body, that is a sense, and we could feel that something is being touched. Then is the smell. How we could smell if it is something good food or the smell of roses is through our nose. And then the taste. The taste is the comes from the tongue. Every time we eat something, we know how good a food tastes. If something tastes bad, we spit it out. So that these are the main five senses that we have in human body. Now comparing to the computer, the sight or the eyes of a computer can be a keyboard, but because you pass the instructions, type the instructions on a keyboard and passes on to your computer. Or you have a webcam, your webcam sees the person or webcam sees the instructions and it passes it down to the operating system, and operating system passes it down to the CPU or memory and so on. Just like that, we also have sensors. Sensors are the ones that actually kicks a computer or activates certain functionality of a computer. So that is also considered as part of a sight sense for a computer. Then comes the sound or ears. What are the sound or ears of a computer? Well, we have a headset that has a mic or an individual mic that we could actually talk to. Nowadays, what are the ears of modern computer? Well, we have Siri, we have Alexa from Amazon, we have Google. So these are all the things when we talk to these devices, we says, "Hey Alexa, what's the temperature today?" Alexa is a tiny device that's listening to instruction as soon as you say, "Hey Alexa," so that is passes down to its memory and to its CPU to process it. So that's the newer sense that I would say in a computer. Then we have touch. For the touch, we have a mouse. We use mouse to move around our cursor. We also have a touch screen we could use to point. We could also use a pen, a touch pen. So these are the different peripherals that are available to us as that performs the function of a touch. Then comes in smell and taste. These two are yet to be discovered, but some people say that the artificial intelligence or the virtual reality are the ones that actually going to take over these two senses, and the computer will become pretty much the same. Will have of all five senses that we have in a human body. So, anyway, this is the lecture I wanted to cover, so you will know and you could compare ourselves, what's inside of our body, to a computer. So when you are troubleshooting or when you are trying to explain something in layman's terms, you will know how an each computer component works as compared to a human body. In this video, we are going to talk about the other internal parts of a computer that are as important as any other parts. The first one we have is the fan or multiple fans inside of a computer. And the purpose of a fan in the computer is to maintain the temperature, because when we are dealing with electricity and running computer parts together inside an enclosed box, which is the chassis of a computer, there is always a chance for overheating. So these fans allow computers to maintain a certain temperature. Then let's talk about the second one, which is the power supply. Of course, we know that everything inside a computer works on a power. So we talked about the computer binary language, which is on and off. 0 and 1 is actually come from the power supply or from the power that we have from the outlet. Then we have the CD-ROM or DVD-ROM drive. This ROM drive is used to actually run certain programs or install certain programs that are downloaded on a CD or DVD-ROM. Now, most of the applications that nowadays we download it off of internet, and they get downloaded in ISO format or exe format. There are different file format that you could download and install. Not a lot of applications nowadays come into a DVD format, just like movies. So everyone nowadays watches movies on Amazon or Netflix. Those movies are no longer available on a media, which is the CD or DVD, where you could take that media and insert into a CD-ROM. So there might be a few computers that still have CD-ROM, but most of the computers that you're going to see will not come with the CD-ROMs anymore. Then moving on to the video cards. These are the video cards that are attached on the motherboard slots. And the purpose of the video card is to output the video of your computer to your monitor. Then PCI expansion slots. Now, depending on the size of your computer or how powerful it is, your computer might have 2 to 5 to 6 or 10 PCI expansion slots. These expansion slots are actually sitting on the motherboard. And the main purpose of these slots is if you wanted to add additional cards or provide additional functionality to your computer. For example, if you wanted to add an additional network card, if you wanted to add additional graphic cards or video card, these ports or these slots are available to you to attach so you could add more resources to your computer. All right, then we're talking about the network cards or built-in network ports. So if you look at the first diagram on the left-hand side, you'll see these are the network cards that we could actually install on our PC expansion slots. This will allow us to add additional networking on our computer. Then we have the network ports that are already attached on the motherboard that comes with the computer. If you look closely, you see right here where I have circled, these are a few network ports that come pre-built with the computer.
Once again, we have our computer open, and this time we are going to look at the other components of the computer. The very first component that we're going to go through is the fan. There are multiple fans inside of your computer, now depending on the size of your computer and how much powerful it is. So one of the fan is on the CPU, so which we have already looked at earlier, that this is a tiny fan that attached to a metallic piece which looks like a radiator, and that whole thing is sitting on top of the CPU. Then we have these main fans. If you're gonna look closely, let me turn this around. See right here, there's one fan here, one fan here. These two fans are basically to keep the entire computer to a certain temperature. So if the computer gets hot, these are the one that gets activated and make sure all of the parts inside of the computer are remain on a certain temperature. Okay, another fan that you'll see, it's right here. You're gonna see a couple of fans on this side. So it depends the size of your computer. So you will see the different instances of the fan. The next one I'm going to cover is the battery itself. Now again, depending on the computer that you have, my whole entire CPU, sorry, not CPU, it's a PSU. It's not a battery since it's a workstation, it's a tower computer. It's the power outlet which is sitting at the bottom of the computer. So right here, I have this little handle. I'm gonna pull this handle out and I'm gonna take this entire PSU. This is the power supply to our computer, and see right here, these are the two fans that are attached to it. It's quite long, and right here, if you notice, that's where our cable goes. It's for us, it's 110 voltage. That's where it connects, and this thing provides the entire power supply to the computer. And right here, you see these two ports. These white ones, these are the ones that actually attached to the motherboard. You see everything is attached to the motherboard. All right, let me slide this down. And then we have the CD-ROM that we already have covered. And then these are the network card right here. If I turn this around again, See, first of all, see this network card right here? See this little network card? This is a built-in network card that is sitting on our motherboard. See right here, if I turn it around, see right here, there is no card. So it's just a port that is sitting on a motherboard, which allows us to connect to the internet, and that's where the Ethernet wire goes. But if you want to have additional network cards or additional network ports, then you could install them on the PCI expansion slots. So right here, if you turn it around, I have these two cards. This is for the output video card if I wanted to have a different enhanced graphic video card. And this is the fiber card actually. So if you wanted to attach a storage to it, by the way, the network is also running on fiber nowadays. So this is the fiber card that I have. But remember, these fiber cards don't come with a computer. You have to order to have that installed in your computer when you get it. So anyway, we have actually covered pretty much everything what's inside of the computer. If you have any questions, please feel free to let me know. Thanks.
Hello. In this video, we are going to talk about the motherboard of a computer. The motherboard is the backbone that ties the computer's components together at one spot and allows them to talk to each other. It is the main circuit board inside of a computer. So if you look at on the right hand side the picture of a motherboard, you will see it's like a flat surface which has all the transistors, it has the memory slots, it has the CPU sockets, and all the devices that we connect on top of it. It has the slots for all of those. So motherboard kind of like brings everybody together. So it connects the CPU, RAM, hard drive, optical drive, video card, sound card, and many other internal components. It also provides you to attach external components to the computer as well. Now, the motherboard is also responsible to distribute power to the various components of the computer. You could connect the power to the motherboard, and that's then the motherboard's responsibility to distribute that power to all the other elements inside of the computer. It is also referred to as main board or main circuit board, system board, logic board, but overall, most of the time, people referred or the technician referred it to as a motherboard. Here are a few popular manufacturers that actually manufacture these motherboards. Number one is Intel, then ASUS, AOPen, ABIT, BioStar, Gigabyte, and MSI. There might be a few other manufacturers, but these are the main one who have the most market share in manufacturing these motherboards. All right, so now we're going to open up our computer and we will take a look together how motherboard is laid out on a computer and how it functions in terms of bringing all these parts together.
Okay, it's time again to open up our computer and find out where that motherboard is. By the way, I already have my strap and right here, and I'm gonna go a little zoom in. Okay, and move this here so you will have a better look of what is inside of the computer. All right, so right here, all the way in the back of the computer, this entire board, which is in my case is blue, and most of the time it is blue, the motherboard. This entire board in the back is the motherboard, which is the backbone of our computer. And if you look closely, every inside component of our computer is attached on that motherboard. So motherboard is the one that you could say allows the communication, the traffic from one component to another. It's like a highway. So right here we have the CPU, we covered that already, that is sitting on top of our motherboard. The memory, the DIMM slots are also on top of the motherboard. We have our disks right here attached to the motherboard. These are our cards that are sitting on the expansion PCI slots right here that are also sitting on the motherboard. Then you have the fans right here. We have a power supply at the bottom right here, and there are certain circuits and transistors that are on the motherboard. Anyway, so there might be a chance if you're getting into the IT job, most likely an IT technician job or hardware support job, then you might have to replace the motherboard, a faulty motherboard, of course. Then what you have to do is basically take out every piece that is attached to this motherboard, and then you will replace this entire motherboard. I know it's not it doesn't look that easy, but it is part of the job. And once you replace it and once you put everything back on the motherboard, then your computer should be back in operational. I'll see you in the next lecture.
Hello, boys and girls. In this video, we are going to learn the most common computer connection that's been used lately to connect other devices to a computer, and that is USB. USB stands for Universal Serial Bus and often referred as plug and play. The reason it is known as plug and play is because all you have to do is plug the cable to the port and start working or using the device that you want to have connected with your computer. So, as per Wikipedia, USB is an industry standard that establishes a specification for cable connectors and protocols for connections, communication, and power supply, interfacing between computers, peripherals, and other computers. Now, in simple words, a USB connection is a standard connection between a personal computer, which is your laptop or your desktop, and most of the other consumer electronic devices such as mouse, keyboard, speakers, storage flash drives, printers, and many, many other peripheral devices that you want to connect to your computer. So that is the standard that's given. Before that, there were so many different cables that were used with so many different devices. If you wanted to connect keyboard, you would have to use a keyboard cable. For mouse, it was different. For printers, for flash drives, any external drives that you wanted to connect to your computer, you have to use different cables with your computer. Ajay Bhatt, who was the main brain behind this technology, worked together with many tech companies and developed USB in 1996. It has replaced interfaces and many other interfaces, such as serial ports and parallel ports. And once again, these ports were the different ports that came with the different devices. So if you're using device A, you have to use its own cable or its own port. All right, one of the advantages of USB connected devices is that the software driver is automatically installed on your PC when connected. Yes, that is the beauty. Meaning, if you have for example, a keyboard and you want to connect to your computer, then when you connect to it, automatically it detects it, it installs its driver, and it starts running right away. Same thing if you have a third party electronic device and you connect to it, you do not have to install its software or driver. That is why, once again, it is called plug and play. And I'm sure everyone has seen how it looks like. Just to refresh our memory, the port on your computer, your PC, will look like this. And the cable that you would need, both ends are the same. You would need that to connect to your port. So that's what a USB device is used. It was a revolutionary invention. It has changed the technology completely.
Hey, wonderful people. In this video, we are going to open up our computer and I'm going to show you what our RAM or memory looks like. where is it located inside of the computer, and how we could remove or replace a memory module that's inside of the computer. By the way, those memories or RAMs, they are this thin little circuit boards that are installed over the motherboard. And they're also called DIMMs, which stands for dual inline memory modules. Okay, so I have this HP PC here. I'm going to put it up right here so you will have a better look. And in my PC right here, it has this side panel which opens up. With the side panel, there is this latch right here. When you lift the latch, it opens the side panel. Now, of course, it depends on your computer or the server that you're working on. If you're working on a server level, usually they are flat and horizontal. So you have a latch on top of the computer where you could open it up and remove the top, and then you could locate the memory DIMMs. Okay, in this one, in my computer, let me zoom in a little. Okay, much better. So let me come around. I will go and take a look inside of our computer together. So right here in the back, very back of this computer is our motherboard. Right here is our CPU, and right here is another slot for CPU if I wanted to upgrade. These are the cards that we have for our network. And right here you see this plastic. This is where the memory or RAM is installed behind this plastic cover. So now we're going to open up this cover. There's this little tab right here. I'm going to push it down and I'm going to take this out. Okay, so let me do a little zoom in more. Okay, so you see right here, these are the memory DIMMs. As you notice, I have 3 of them. Each DIMM that I have is 2 gig. So that makes my computer 2 plus 2 plus 2, 6 gig of RAM. You see right here, these are the empty slots for my RAM. If I wanted to upgrade my RAM because I need to run certain applications that require more memory, then I could purchase these memory DIMMs and I could add them to these slots. And of course, it is always recommended that you go with the same size of DIMMs that you already have on your computer. So if I have 2, then I should go with 2, 2, 2. So 6 plus 6, I will have 12 gig of memory. Okay, now comes the time how we could take one out or replace one. So you see right here, each memory DIMM, these have a little white tabs here, one on the left, one on the right. You have to push it down and push it down from the other side as well. And then simply take out this memory. Now, this is the memory card or DIMM. And please make sure, if you notice closely, it has this little groove here. This is our little guide that when we are inserting this in, we are not inserting upside down or the wrong way. So that is why there's this little groove here. This DIMM also have its serial number, the manufacturer, and the size of this DIMM. Now, if you wanted to add or replace it, let's say, for example, if it's a faulty DIMM, then you could get a new one. And with the new one, you could do the same thing. All you have to do is align with the slot, start with the left corner and the right, and then push it down a little bit on the left corner. Once it's in there, all you have to do is simply push it in. As soon as you push in, you're gonna hear the clicking sound, which means these tabs, the left tab and the right tab, they are snapped in and they are grabbing your memory modules. So this is how you replace a memory modules or RAM in your computer. Please make sure before you open up your computer, please make sure your computer is unplugged and it's not connected to the power. And then you could definitely try to locate where your memory is in your computer. I'll see you in the next lecture. Hello again. In this video, we are going to look at our CPU. A CPU, we know it's a brain of our computer. We're going to open up our computer and we're going to see how a CPU looks like, how we could replace it, and where exactly it can be found on your motherboard. I am using my same HP computer, and I'm going to turn this around and zoom in, so this way you will have a better look inside of my computer. Okay, so if you look at this computer, you're going to notice, or if you open up your own computer, you're going to notice anything that is a little bigger and looks metallic more, and it has a fan attached to it. This is not a CPU. A lot of people confuse that with the CPU. It's basically a fan which actually sits on top of your CPU to make your computer cool. So you would have to remove this. There are usually screws on top, and those screws actually go all the way in to your motherboard. You have to unscrew it. Again, before you touch anything, make sure you wear your static band. You make sure your power cable is unplugged. So I have already loosened up these screws. So one screw is still holding on, so I'm gonna unscrew this. Okay, you see, once I unscrew it, this thing comes off, and if you turn it around, see this metal piece right here? This actually sits on top of our chip, which is the CPU, and it has this little fan right here which keeps your computer cool, and it has this wire attached to your motherboard. If I take this wire out, it's not gonna run. Of course, that's where it's getting its electricity. Okay, anyway, let me put this right here, and let's go and look at our CPU. Okay, so let's zoom in a little more. So as you notice, I have two sockets in my computer. One socket is right here, which has no CPU chip, and the other socket is right here, which actually has one CPU. So my computer only has one CPU, and I do have the option to upgrade to two CPU if I want to. So let's first look at the one that does not have a CPU. It has this little handle right here, and you have to push this handle back so it could open up, and this thing, it has a little door that you could slide on the left, and you pull this opening, pull this plastic piece out. You see, this is just an insert, just a plastic, a placeholder. So as you open this, you're going to see all those little chips up here, and the circuits actually. That's where you actually put in your CPU, and then once it's installed, you close the door again, and you close that little handle to keep it tight against the motherboard. Now coming to the one that we have a CPU, let's open up the same way. Okay, let's open the door, and let's take our CPU out. See, right here, this is actually the CPU, and mine is a single core CPU. So this is how it looks like, and you see it has this plastic thing or a paper smudges on top. This is where our our fan sits on to keep it cool. To install it or to replace it, again, this one has a little guide, these grooves here, these little grooves right up here and at the bottom. This will allow you to put them in to the right place without incorrectly inserting this way or that way. So let's put them in. Okay, close the door and put the handle back on, the arm it has, which holds the CPU tight. Then you could simply put the fan back on. By the way, when you actually going to buy a new CPU, you'll have to get that fan. Most likely it will come with the fan if you are putting a whole new CPU on the socket right here. Anyway, this is all about the CPU. Again, please remember CPU is the brain of the computer. It performs one of the main functions on your computer, and this video was to show you how we could replace or find a CPU in our computer. All right, see you in the next lecture.
Hi, in this video we will talk about GPU. GPU stands for Graphical Processing Unit, and it actually functions similar to CPU, but it handles the programs, or more specifically, graphical processing a lot faster and parallel, meaning simultaneously it handles many tasks at the same time. Keep in mind, you can run your computer without a GPU, but you cannot run a computer without a CPU. GPU allows graphic programmers to create more interesting visual effects and realistic scenes with advanced lighting and shadowing techniques. Moreover, GPU unlock new possibility not only in gaming or graphic world, but also in content creation, machine learning, artificial intelligence, and much, much more. It is specifically designed to accelerate computer graphic workload. Yes, so if you know someone who is in gaming world or love to play games or advanced level games, they gotta have a GPU in their computer. Or they will find a way to add a GPU card into the computer so it does a lot faster processing and the graphics of their computer games become a lot crisper. There are two type of GPUs. One is integrated GPU, which looks a lot like a regular CPU. Well, if you open up your computer that has a GPU integrated to your motherboard, you might not be able to identify it because it will look a lot like a CPU, and usually it is sitting next to the CPU. It is a built into the motherboard and cannot be upgraded or replaced. It does not come on its own separate card and is instead embedded alongside the CPU. Now let's talk about the discrete GPU. A discrete is mounted on a graphic card that attaches onto a computer's expansion slot on the motherboard. This kind of graphic card is replaceable, so it can be upgraded. This way your computer won't be obsolete. The graphic card is like a smaller version of a motherboard with its own memory and cooling fan. So the condition is your computer gotta have an expansion slot on its motherboard available so you could insert this card onto it. But if it does not, then you pretty much out of luck. You cannot put it inside of your computer. Just like laptops. If you have a laptop and you want to use a GPU, of course, you cannot open your laptop and insert this graphic card into it. So what do you have to do then? Then you could buy an external GPU. Yes, there are many manufacturers who build external GPU that will help you enhance your graphics for your computer. So definitely find them out. Anyway, that's pretty much about the GPU. It's very simple. The only difference between, I would say, the CPU and GPU is GPU specifically designed for your graphical needs. Hello, ladies and gentlemen. In this video, we are going to talk about the most common display interfaces or cables that are used to connect your computer to a monitor. There are six display interfaces that we are going to talk about. That's the most common one. There are a lot more, I'm sure, but the ones that you should really need to know that concerns you for this course are as follow. The first one is VGA, and then HDMI, DVI, DisplayPort, USB-C, and Thunderbolt port or cable. So we'll cover them one by one. So the very first one we'll go with is the VGA. VGA stands for Video Graphics Array. It is an analog interface between a PC and a monitor that was widely used prior to DVI, HDMI, and DisplayPort. VGA was introduced on the IBM PS-2 platform in 1987. It was a common to see VGA connectors on televisions, laptop, computer monitors, projectors, and other devices. VGA port or cable only carries visual, meaning video. Another source needs to be connected for audio signals. Yes, that one cable of the VGA that you see does not carry audio with it. You would have to connect separate cable for it. So here is the port that you I'm sure very familiar with and have seen with many of the computer that are older computers that comes with this type of port. Now this port is a 15 pin female D sub port. That's what it's called. It has 15 pin holes. The D shape ensures that VGA cable will only fit one way round, and it is often colored blue or black. Yeah, so you're not gonna make a mistake and you're not gonna bend the pin if the first rounded or D shaped is not fitting on the port correctly. Now, as for the cable, you'll see right here, the cable is also a 15 pin male D sub port. These ones are the actual pins that goes inside the holes of the D sub port. The computer unit or your PC and the monitor both should have female ports in order to use this cable. Now, once again, this cable only carry video and does not carry audio. HDMI. HDMI stands for High Definition Multimedia Interface and is the most frequently used high definition signal for transferring both HD audio and video over a single cable. The HDMI is mostly found on TVs, video projectors, PC monitors, DVD Blu-ray, Ultra HD players, cable satellite boxes, and so many other devices. I am sure you pick up any device in your home and most likely you will find the HDMI port on it. HDMI is much better than VGA for several reasons, and one of them is not only is HDMI capable of transferring more data, it also carries audio. Yes, with VGA, that's not possible. You gotta have a second cable. Now, this is how the port looks like on your device. And here is the cable. Both ends are the same. It doesn't matter which end goes on which device. Then comes mini and micro HDMI. There are three types of HDMIs. Standard is called type A, which we have already talked about. Mini is called type C HDMI, mostly found on cameras, camcorders, and tablets. And then micro, which is a lot smaller than standard and mini, and that is type D, mostly found on compact mobile devices such as smartphones. And looking at the picture of the ports, the middle one is this type A standard port. The top one is mini and the bottom one is micro HDMI. And these are the different cables that you would need to connect from on all these different ports. Now, probably you have a regular port on your device, and on the other end of the device, you have a smaller port. For that, you could use adapter, a connect adapter, which could translate from smaller to the standard types. Moving on to DVI, stands for Digital Visual Interface. It is a video display interface developed by Digital Display Working Group, in short DDWG. It is used to connect a video source, such as a video display controller, to a display device, such as a computer monitor. It was developed with the intention of creating an industry standard for the transfer of digital video content. DVR connection is starting to die out now because newer technology has taken over, such as HDMI, digital port that we'll cover later on, Although it is still on every graphics card, the video signal is basically the same as HDMI, just without the audio. Same problem, just like VGA. Single link DVI-D connectors have 19 pins, and dual link DVI-D connectors have 25 pins. Of course, the more the pins, the higher bandwidth and the resolution. And this is how a DVI-D connectors look like, and these are the cables. Then, just like HDMI, it has mini and micro DVI ports and cables as well. Three types: standard, mini, and micro. And that's how the mini DVI and micro DVI ports looks like on your computer. By the way, don't focus too much on DVI. As I said, it is a going away, obsolete technology now. All right. Then we have DisplayPort. All right. The interface is primarily used to connect a video source to a display device such as a computer monitor, and it can also carry audio, USB, and other forms of data. DisplayPort was designed to replace VGA and DVI. The interface is backward compatible with other interfaces, such as HDMI and DVI, using either active or passive adapters. Now, here is the DVI looks like on your computer or your laptop. And here are the cable. Both look the same. Again, doesn't matter which end of the cable that you pick to connect to either side of your device. Now, it has a mini display port as well. Early versions of mini display port can display the same maximum resolution as the original size display port. The reason we had the mini one, so it could be used on a smaller size devices or mobile devices. But now the newer versions can carry more bandwidth and provide higher resolutions. So here, if you look closely, if you have the latest laptop, you will see a port will look something like that. And here is the cable, smaller size cable for display port. And if you wanted to use the adapter, if you, let's say, if you have a computer that uses the regular standard display port, you could connect the one side of it with that cable adapter and the other side with the mini display port. All right, moving on to the USB-C, one of the fastest technology and the coolest one. Stands for Universal Serial Bus Type C. Same as USB that we had or we have been using in our computers, but with the extension of Type C. It is the most advanced technology that can be found on most of the newer laptops and mobile devices. If you have the most recent on the most newest computer or laptop right now, I bet you would have that port on your computer. Now, why do we use that? USB-C is relatively new connector for delivering data and power to and from computing devices. When you connect your mobile device to a USB-C computer, you can transfer data such as photo, video, and audio files up to 10 gigabyte per second. A lot faster. It is not like the regular old USB. It is a lot faster. Now, USB 3.1 cables can deliver 4K Ultra HD video and audio from your laptop phone or tablet to your HD TV or monitor. The USB-C standards include both DisplayPort and HDMI. So you will want to either USB-C to HDMI DisplayPort, or if you have a very new monitor, USB-C to USB-C will be available, I am sure. So you don't need an adapter. It is only for those who has an older um, display, then you could use that adapter. Now here is what it looks like. Pay close attention. If you have a laptop, a newer version laptop or a computer, look at it and you will see it looks like a rounded, sheer, smaller USB port. The older USB, the regular USB port is kind of like a square. This one is rounded edges. This is the cable that it comes with. It carries the data, the video, the charging a lot faster than a regular USB. Then comes the Thunderbolt. The Thunderbolt or Thunderbolt T ports looks like the same as USB-C ports on your computer. And the connector is physically the same from a plug-in perspective. Thunderbolt 3 lets you transfer data up to 40 gig per second. That's a lot faster. That's twice as fast as the 20 gig per second maximum throughput speed for the fastest USB-C ports. Yes, USB-C port, the latest version can carry 20 gig, but the Thunderbolt carries 40 gig. So you connect it, the transfer data is a lot faster. The display is much clearer, the resolution is a lot higher, and the charging of your device is going to be a lot faster. So this is how it looks like on your computer port once again. This is same as USB-C, but if you look closely, you will see like a thundering arrow, which is referring to as Thunderbolt, as a label on that port, which will tell you that it is for Thunderbolt charging or display. All right. So these were the few common display interfaces and cables that are being used nowadays. So you should definitely pay close attention to this last slide because most likely you will be using and working with USB-C and Thunderbolt type of technology cables and interfaces from now on.
Hey guys, in this video I wanted to talk about the anti-static wrist strap, or sometimes people call it a wristband. When we are dealing with the hardware and we have to replace the internal components of the computer, we have to make sure that we wear this anti-static strap so we won't damage the internal parts of the computer. And how it helps? Well, this anti-static strap, it actually prevents the damage to our computer by preventing the electrostatic discharge, which is sometimes referred to as, in short, as ESD. ESD is, what is an ESD first of all? So ESD is like a transfer of a natural occurring current that's inside of our body to another surface. So when this transfer happens, it could cause damage to our internal components of a computer. So you probably, I'm sure everyone in their life have experienced that sometimes when you walk on a carpet with your socks and then you reach a doorknob, you get a static. That's a static that actually generates inside of your body. So when you have that type of static and you're working on the computer without this, yes, you could seriously damage the internal components of the computer. So it's very easy. All you have to do is attach this strip where the Velcro is on your wrist, and then the other end of this strap, which is right here, is a clip. Then you should attach it to any metal surface of your computer. I usually attach it on the back. See, it has a metal surface. But if you have the computer open, you could also attach where the encasement of the disk drive is. That's where the strip goes for the metal surface too. You could attach it there too. It is very, very safe. And it will, again, if you're working on a production server in a corporate environment, those hardware, the internal components of the computer are very expensive. And you do not want to take that, your body current, the static, and transfer that to the inside of your computer components. So please make sure you buy this when you're going to start a job. I'm very sure your employer will give you one of these to work on if you are dealing with replacing the computer hardware. And if you wanted to try it out, it's not very expensive. It's cost me $3 USD, $3. You could buy it and you could try it out for your lab computer or anything like that. I'll see you in the next lecture.
Hello, everyone, and welcome back. We have a good understanding of computer hardware. So I think it's time we should also know and learn about hardware vendors and people or the companies that actually manufactures that hardware. And the number one in line we have is Dell EMC. Dell is an American multinational computer technology company that develops, sells, repairs, and support computers and related products and services. It was founded by Michael Dell in 1984. Dell also acquired EMC, which was the storage company, in 2015. A lot of our computers, workstations, or laptops, they are also manufactured by Dell or HP. But most of the computers that we see on the corporate world, the servers, the stackable servers, are manufactured by Dell. Then comes in HP. HP stands for Hewlett Packard. It's an American multinational company headquartered in Palo Alto, California, that developed and provided a wide variety of hardware components. It merged with Compaq in 2002, and it was founded by David Packard, Bill Hewlett in 1939. That's why Hewlett, the last name of Bill, and the last name of David Packard, they combined the last names and created the company Hewlett Packard. A lot of our servers in corporate world are actually manufactured by Hewlett Packard. Then comes in the IBM, as IBM stands for International Business Machine Corporation, and it's American multinational company headquartered in Armonk, New York, with operation over 170 countries. It was founded by Charles Renelt Flint in 1911. So IBM is one of the oldest computer companies in the world. Okay, then we have the next one in line is Cisco. Cisco Systems Incorporation is an American multinational technology company headquartered in San Jose, California, in the center of Silicon Valley. Cisco develops, manufactures, and sells networking, mainly networking, and then compute hardware, software, telecommunication computer equipment, and other high technology services and products. So whenever you hear the word Cisco, you always think of networking devices like switches and routers and firewalls. But now Cisco has entered into the compute hardware, or building the compute for corporate world. Okay, moving on. Sorry, I missed the last. It was founded by Sandy Lerner and Leonard Pozak in 1984. Okay, now moving on to Oracle. It's an again American multinational computer technology corporation headquartered in Austin, Texas. Oracle acquired Sun Microsystem in 2009, and it was founded by Larry Ellison, Bob Miner, and Ed Oates in 1977. Sun Microsystem is another hardware company that actually manufactures its own hardware, and it has its own operating system, which was Solaris. They run on Spark initially, and now they also run on x64-bit operating systems. Then next in line, Lenovo. Lenovo Group Limited, often shortened to Lenovo, is a Chinese multinational technology company incorporated in Hong Kong, and it was founded by Liu Chuanzi in 1984. Hopefully, I'm pronouncing it right. Then comes in Hitachi. Hitachi Limited is a Japanese multinational company headquartered in Chiyoda, Tokyo, Japan, founded by Namihi Odara in 1910. Hitachi is also very much involved and has one of the biggest share in storage market. Then we have Intel. Intel Corporation is an American multinational corporation and technology company headquartered in Santa Carla, California. It was founded by Gordon Moore and Robert Noyce in 1968. Not only they hold the biggest share in CPU market, we know that Intel chips are very famous, but they have started manufacturing high-end servers as well. So in corporate world, we do see a lot of computers, servers that are manufactured by Intel. Anyway, please keep these companies in mind. Once you enter the IT world, you will have to know these companies, what kind of hardware do they manufacture, what is the hardware models and series that they have in certain years, and what do they have as a current models, what kind of power they come with. So you're going to be dealing with a lot when it comes down to purchasing or getting your hardware requirement and resource requirement. Hello again. In this video, we are going to cover another important computer hardware, and that is hard disk drive. Now, I got this definition from Wikipedia, and it's very easy and self-explanatory. And it says a hard disk drive, which is HDD, is an electromechanical data storage device that uses magnetic storage to store and retrieve digital information using one or more rigid, rapidly rotating disks. And that is also called platters, coated with magnetic material. Now, to make it more simpler, a hard drive is a hardware component that stores all your digital content, and such as documents, printers, music, video, programs, applications, and even operating systems. Now, hard drives can be external or internal, so it could be mounted inside of your computer, or if you need additional space for your disks for your storage, then you could attach an external hard disk to your computer. Hard disk is a long-term memory of your computer, whereas RAM is a short-term. So every time you start up a program, that program is actually saved in RAM. You make changes to that program, or you make changes to your document. As soon as you close the document and you save it, it gets saved on your hard disk, and it actually memory releases that from its memory. So it's a similar concept as in human brain, that way you have a short-term and long-term memory. If I ask you what is your second grade teacher, then you probably have to really think hard, go to your hard disk drive in your head and retrieve that information. You'll probably be lucky if you could pull that information within a few seconds, but you're going to have a hard time remembering it because it is saved somewhere back in the hard disk. But if I ask you what is your brother's name, then you will tell me right away because that is always stays in your memory. You use that name almost every day. Now let's take a look at the layout, the physical layout of our hard disk. Now if you go and open up your computer and you pull out your hard disk, you will see it is actually um, an encasement. It's looks like a rectangular casing, and when you open up that further down, you're gonna see inside of this hard disk. Now, if you pay close attention, this hard disk has four platters. See right here, one, two, three, four. They look like exactly like a CDs that we have or DVDs, but they are stacked together. So in this disk, we have four disks together, and they are combined together with this middle piece that's called spindle. Spindle allows these disks to rotate, spin. And then you have the slider, the head of which actually reads these disks. So you could write and read through this head. Okay, moving on to the next slide. Here we are actually drilling down to the actual platter, how the data is saved. Now, this entire disk that you see looks like a CD. That's called platter. And right here in this example, we have two platters. In the middle, as we discussed, this is a spindle that actually holds these platters and helps them to rotate. Now, this right here is a disk sector. This entire chunk right here is a disk sector. This is the arm, and the arm has this little tip in front of it, and that's the little head. Now, if you notice, each disk right here, right underneath the first disk, right underneath, there's another arm which reads the information or pulls or retrieve or write your data to the second disk. Similarly, you see there's a third arm right here, which is actually sitting on your third disk, which is doing the same thing. It has a head and it is reading and writing. So there, if you have three platters, then you're gonna have three arms. Now, this is the track. So each disk has a long track, just like as if you are on a running track. It has all its tracks. Now, each track on a disk has a sector right here. Now, this is a disk entire disk sector, but this is a track sector. Now, inside of this track sector, this little blocks, these little chunks that you see, these are the actual files that you have saved on your computer. Either it could be image file or video file or a regular text file, anything. So they are saved little by little in chunks onto these track sectors. And if you are trying to save file 2, it is possible that it could go to the second sector, sorry, second platter, and the second arm will come into use to place that into the second sector. So that's how hard disk works. Now let's go and open up our computer and let's take a look at the actual disk from inside of our computer.
Okay, so here we are. You have a good understanding what a disk is and what is inside of a disk. So when you open up a disk, you'll see there are platters. Each platter has a sector. There's a head that reads and writes to those platters and so on, which we covered. Now it's time to look at that disk. Where can we find that disk or hard disk inside of our computer? All right, so I am going to turn this around. I already have the side panel of this computer open. Okay, by the way, this time I'm using the wristband to avoid the static. And I'm gonna use this pin, this clip, to attach it to somewhere that is metal. So there is no static. So disk, when you're gonna look at the disk in the front of it, you're gonna see that right here, this is the CD-ROM drive, which is the drive where we put in the CD-ROM. But the disk has to be somewhere underneath or on top of it. So let's turn this thing around again. See right here, I have these two disk slots, hard disk slots. I'm gonna open the bottom one. There is this little latch here, a tab which you press it down and it opens or releases the handle. So pull down the handle and simply pull out the tray. So right here, it's the actually empty insert for this disk. If I wanted to add another disk to my computer, I do have another slot to add a disk. So my primary disk is not here. I could see that. So I'm gonna push this back in. Then I'm gonna open the top one and I'm pretty sure my main disk is right here on the top one. So let's push the tab down, pull the lever down and pull it out. Okay, very good. So the disk came out. So this is how the disk looked like. This is the encasement of the disk. You could actually open this up. If you look closely, you're gonna notice it has these screws. There is information about this disk as well. It has a serial number, it has a pin number. It also tells you the size of your disk. So right here, the size of the disk is 320 gigabytes. So this is the disk. If you want to open up, make sure you know how to put it back. I don't recommend that you open up if you have a production or some important information saved on this disk. All right, so that's pretty much about the disk. I'll see you in the next lecture.
Hello boys and girls and welcome back. In this video we are going to cover the external components of a computer. I am sure many of you already know this, what are the things that are attached to your computer, but we will take a quick moment to go over this lecture. So we have our computer and very first thing that we usually see attached to this computer is a monitor. And monitor is the place where we will see exactly what's going on the computer. Then we execute those commands, certain things that we wanted to run on the computer through our keyboard and mouse. These devices are the input devices that actually goes to the computer, tell the computer what to do, and then once the computer finish executing it, it throws that out on our monitor to see or verify it. Other type of input and output device that we have that we attach to our computer is the printer. So if you wanted to print a document, we could send that command or that instructions through our keyboard or mouse to our printer. Printer will print that document. Similarly, if you wanted to scan a copy of a document and we wanted to have a copy of that scan saved on our computer, that's going to be input coming into the computer file. And also, it has other functionality like scanner as well, and photocopy and other stuff. Then there is another outside external component that is a webcam that's mostly used nowadays. A lot of people work virtually, so I'm sure every one of you have a virtual camera, a webcam, sorry, that you attach to your computer through USB, and it actually captures your video. Then headphone, if you are using your computer heavily to talk to people, then you would need a headphone with a mic. Then a lot of people who have less disk space on their computer internal hard drive, then they attach an external disk drive. And from some speakers, if you are not satisfied with the quality or how high your computer's speakers go, then you could attach an external speakers to your computer. And by the way, these external components of a computer are also called computer peripherals. So if someone is asking you, hey, do you have this computer peripheral? Please make sure they are telling you that this is a computer component that's outside of your computer. Hello everyone. In this video, we are going to cover a very interesting topic, and that is what is the difference between 32 and 64-bit processor. I'm sure a lot of people ask this question when they go buy a computer. But nowadays, a lot of computers, I would say most of the computers come in 64-bit processor, as 32-bit is an older version or older model of computers. All right, so let's get into what is the difference to clarify what's the confusion that we have. A processor, first of all, is the same as CPU, which stands for Central Processing Unit, which processes the instruction that come from programs, the operating system, or other components in your computer. All right, so let's put it this way. CPU, we know, gets the unit of data or that information from RAM. RAM is memory, and when it gets it, it processes it. Now, if your computer is 32-bit processor, then it can only process 2 power of 32 memory addresses, and that equates to 4 gig of RAM. So it means your computer cannot process more than 4 gig of data at a time. All right. Now, in computers, there is only binary. We know that. It's only 0 and 1. Each one is considered a bit. That means for 1 bit computing, you get 2 possible values. 2-bit means 4 values. Then at 3 bits, you double that to 8. All right, let me put it in a graphical way. So the picture speaks 1,000 words, right? So we have our computer, and we want our computer to do the computation of 2 plus 2. Now, there's one thing we do need to understand, that there are 8 bits in 1 byte, and 1024 or 1024 bytes in 1 kilobyte. 1024 kilobytes equal to 1 meg, 1024 meg equal to 1 gig, and so on. Now, going back 8 bits to 1 byte. So 2 has 8 bits, another 2 has 8 bits. So this is how it is right now sitting on your disk, because computer doesn't understand any other language but 0 and 1. So when we do 2 plus 2, it's basically going to do 0011 0010 plus 0011 0010. And then from the disk, it's going to pull that information. If it is saved, then it's going to hand it over to your memory. Okay, memory. If it is 4 gig of memory, it could actually capture the entire 4 gig of your data units, and it could hand that over to the CPU to process it. Now, if your CPU again is 32-bit, then that memory cannot let CPU process anything more than 4 gig. It has to be equal or less than 4 gig of data. That's what really a 32 versus 64-bit processor is. Okay, moving on to the next slide, we will look at the chart, which is our values for our exponents. So 2 to the 0 value equals to 1, 2 to the 1 equals to 2, 2 to the 2 power equal to 4, and this is the basic mathematics that we have learned when we were kids. So that's what we call an exponent value. So you do 2, if it is 2, then 2 times 2. If it is 2 to the power to 3, then 2 times 2, then equals to 8, and so on. So if we keep going and keep going to 2 to the power 32, and put it at as exponentially, then eventually you're going to get the 32-bit worth 4.3 billion. It means it could process 4.3 billion of data units at a time if it is a 32-bit processor. Now, if it is a 64-bit processor, which is going to be 2 to the 64th power, is worth, wow, 18 point quintillion and change. That's so much I cannot even translate it into how many gigabytes it will be. So now your processor it becomes so powerful that it could process so many of that data unit in a shot, and it could take that from your memory. So let's it usually doesn't happen, but let's say if your memory has a 60, sorry, 8 gig, and your processor is 32-bit, it's not going to work because your processor can only handle 4 gig at a time. If you want your computer to process more than 4 gig of memory, then you need to have a 64-bit processor. All right, so again, let's look at this. This is the R value 4.3 billion. When we divided it divided by 1024, that equates to 4194304 kilobytes. Now, if you take that same value and divide it by 1024, that equates to 4096 megabyte. If you take that same value, 4096, and divide it by 1024, that equates to 4 gig. And that's what the 4 gig is about, the memory card. If you have a 4 gig of memory card, then you could have 32-bit of processor. But if you want a bigger or higher memory, then you cannot go with 32, you gotta go with 64. Let's look at the quick brief history of our processors, how they came into being. The Intel 8080 chip in the 1970s supported 8-bit of computing. That's so low. Now, in 1992, Windows 3.1 was the first 16-bit desktop version of Windows. Then came the AMD. AMD shipped the first 64-bit desktop chip in 2003. Apple made the Mac OS X version, the 10 Snow Leopard, entirely on 64-bit in 2009. And then moving on to smartphones, the first smartphone with a 64-bit chip was iPhone 5S in 2014. So as we're moving into the new eras, this processing speed is increasing. The demand for running our applications and those application requirements to have certain memory is increasing. So that is why your 32-bit processor cannot actually accommodate that type of computation at one time. So that is why all of our computers nowadays coming with 64-bit processor. Hello and welcome back to our next type of software, and that is the application software. Again, if you remember and bring that picture in your mind, you have a hardware, you have an operating system, and on top you have an application running, right? So that's what we are going to talk about. So anything that you have that does not manage your computer or work for your computer hardware, that is an application software, simply. So, application software, also known as end user programs or productivity programs, software that helps the user in completing tasks such as doing online research, jotting down notes, setting an alarm, designing graphics, keeping an account log, doing calculations, or even playing games. All right, let's look at the few example of application software. The word processor. So, not specifically the Microsoft word processor, but most of the operating systems they come built with word processor. And some of the operating systems that don't, then you could go ahead and install as an add-on application software. And we all know the word processor allows you to write letters, applications, write stories, or whatever that you want. Another example of application software is our database. Now, you probably heard of database MS SQL, MySQL, Postgres, all of those actually manages your data, actually are the software as well. That's a software layer that is written in a code. Another example, accounting or financial software, like accounting software would be an ERP application, PeopleSoft application, SAP applications. Those are written by people, and those applications run on top of the operating system. Moving on, multimedia software. We have a lot of softwares that does the encoding of your content, modify the content, edit the contents. Those are applications too. Okay, so next one is the education and reference software. There are many software. If you are going in a college, they would have probably provided you a portal where you could log in, check your assignments, submit your homework. Those are the applications that are actually running on a computer as well. Then the email application software, for example, Outlook, Gmail, we use many different type of applications. Also, in corporate world, they do have a dedicated applications that allow you to check your emails. Then we have graphic software. Most of these graphic software are available on Mac computers where this is most likely for those who deal with the designing graphics. And the last one, we have Internet browser. We use Google, Chrome, Firefox, Internet Explorer. Those are all applications that actually run on your operating system. And by the way, these all application software are just a few list of the software that I have. There are many, many other application software that actually run on your operating system. And many times you have to make sure the software version of that application is compatible with your operating system. Hello and welcome back to our next type of software, and that is the application software. Again, if you remember and bring that picture in your mind, you have a hardware, you have an operating system, and on top you have an application running, right? So that's what we are going to talk about. So anything that you have that does not manage your computer or work for your computer hardware, that is an application software, simply. So, application software, also known as end user programs or productivity programs, software that helps the user in completing tasks such as doing online research, jotting down notes, setting an alarm, designing graphics, keeping an account log, doing calculations, or even playing games. All right, let's look at the few example of application software. The word processor. So, not specifically the Microsoft word processor, but most of the operating systems, they come built with word processor. And some of the operating system that don't, then you could go ahead and install as an add-on application software. And we all know the word processor allows you to write letters, applications, write stories, or whatever that you want. Another example of application software is our database. Now, you probably heard of database, SQL, MySQL, Postgres, all of those actually manages your data, actually are the software as well. That's a software layer that is written in a code. Another example, accounting or financial software, like accounting software would be an ERP application, PeopleSoft application, SAP applications. Those are written by people, and those applications run on top of the operating system. Moving on, multimedia software. We have a lot of softwares that does the encoding of your content, modify the content, edit the contents. Those are applications too. Okay, so next one is the education and reference software. There are many software. If you are going in a college, they would have probably provided you a portal where you could log in, check your assignments, submit your homework. Those are the applications that are actually running on a computer as well. Then the email application software, for example, Outlook, Gmail, we use many different type of applications. Also, in corporate world, they do have a dedicated applications that allow you to check your emails. Then we have graphic software. Most of these graphic software are available on Mac computers where this is most likely for those who deal with the designing graphics. And the last one, we have internet browser. We use Google, Chrome, Firefox, Internet Explorer. Those are all applications that actually run on your operating system. And by the way, these all application software are just a few list of the software that I have. There are many, many other application software that actually run on your operating system. And many times you have to make sure the application version, the software version of that application is compatible with your operating system. Hello, in this video we are going to talk about the very first type of software, and that is the basic system software, a software that you need to run on your computer in order to manage your computer. So system software lets you communicate between the other software and the hardware. Following are a few examples of system software, and we'll go over them one by one because there are additional or sub software of a system software. And the very first one we all know is the operating system. Operating system is also a software that is written in C, C++, all those different languages. And we know for sure, without going into any details of operating system, we know the type of operating systems of software are like Windows, Linux, Mac OS, Chrome, Solaris, AIX, HPUX, and so on. All of these operating systems are basically the software as well. All right, next type of software is the firmware. A firmware is the operational software embedded within ROM chip on the motherboard. Yeah, so there is that little chip that is located on the motherboard, and it has that software written on it, and that ROM is read-only memory, so that cannot be changed. It has a set of instruction and sequence that are managed and executed before operating system starts. BIOS is an example of a firmware. Also, I believe the firmware, the name that was derived from was actually the people or the manufacturer who manufactures those hardware. So those manufacturers are the firms. So they came up with a firm and their ware, so their own software by that manufacturer. What they do is they build that. So if you notice, every time you turn on your laptop or your computer, what's the very first thing you see on the screen? If you have a Dell laptop, you're going to see the Dell logo. If you have an HP laptop, you're going to see the HP logo. Now, how does it come up on your screen? It's because of that firmware that the vendor has already installed on your computer. As soon as you turn on your computer doesn't know what operating system it has. It only knows that it has to look for its firmware that it came with from the manufacturer. Then the firmware tells the hardware, hey, there it is, your operating system. Go ahead and start up. All right, moving on. Then we have drivers. Those are also the software. So driver software is a type of system software which brings computer devices and peripherals to life. Drivers makes it possible for all connected components and external add-ons to perform their intended task and as directed by the OS. Without the device drivers, the OS will not be able to communicate with the attached devices, and all device drivers come with the device manufacturer. So, if you have, for example, a keyboard, a mouse, external hard drive, printers, display, all of them, when you connect to your computer, they come with a device or that component driver that you have to install on your operating system. And that driver is actually a software that allows that to communicate that device to the operating system that's running on the computer. So manufacturers of those devices are responsible to build those software. All right, moving on, the utility software designed to manage the performance of your hardware and application installed on your computer. All right, examples of utility softwares are system backup software, logger or log monitors, disk cleaner, or security software. So when you have a computer and when you buy a computer and you have, for example, it comes with Windows 10. You probably notice it has a pre-built software on them that comes with it, like antivirus software if you want to defragment your disk, if you want to clean that, that are not part of like, I mean, you could consider as part of operating system software, but they are built separately and they are put onto that operating system and they were delivered with your laptop. So these are the utility softwares that are used. Now, when I say system backup software, those are the internal applications or software that are on your computer. Those are not the third party software backup solutions, which we will talk about when we're going to look at the application software. Hello everyone. In this video we are going to cover how internet works. Internet is a vast network that connects computers all over the world. Through the internet, people can share information and communicate from anywhere. So to better understand how internet works, let's visualize it. We have our computer and when we power it up, we want it to go to the internet. So we will double click on our browser. So our browsers are like Internet Explorer, Firefox, or Google Chrome. And then let's say we wanted to go to the page google.com. How your computer knows how to get a Google page or Hotmail or Facebook page or any other page for that matter. It sends that request to a router. Your router is the router or a modem that is provided to you by your internet service provider. That internet service provider, of course, charges you a certain amount per uh, as per the bandwidth or on a monthly basis. Then that ISP, when it gets that request, it sends that request over to another server that is called a DNS, and DNS gets that information to the internet, and that's how you get the page of Google. Now, in this entire process, you're probably wondering, what is a DNS? Well, DNS plays a very critical role in this entire process. DNS stands for Domain Name System. It's basically a database that keeps the records of IP addresses to hostname to, IP to hostname, and hostname to hostname. So, why do we need to keep track of that data? It's because when we go to the URL www.google.com, our computers don't understand letters. They only understand the digits or the IP address that associated on that computer. So when you go to your router says, "Hey, who is google.com?" Then router sends it to ISP. It says, "Who is google.com? I don't understand because it has to be an IP." So then it consults to that DNS server. And DNS server says, okay, you know what? Hold on a second. Let me find out who is google.com. And then it checks its record and says, ah, I found it. Google.com is this IP 205, 203, or whatever that IP address. And that IP address is actually served back to your computer, and your browser translates that IP back to google.com. So who manages how many servers? What are those DNS servers? There are altogether 13 root DNS servers in the world today, and they all labeled starting with A to M. These DNS servers are the one who keep track of all these records. If you go and buy a website, for example, imranafzal.com, you need to register that website. Now, if someone needs to access that website, then I have to have that record of that website to be created in one of those 13 DNS servers with the IP address, that static IP. So this way, every time someone tries to reach me, they can get that translated to a right IP, and that right IP gets associated to a server where that host or where that website is hosting. So what are those 13 servers? Those 13 servers starts with A through M. On the second column, you're going to see it has its IPv4 addresses and also IPv6 addresses as well. On the last column, you're going to see the operator or the company that owns or manages those DNS servers that are responsible to continue to update across all those 13 DNS servers. All right, so Let's log into our Windows and Linux machine and let's take a look how DNS works when we try to reach Google. So I am going to start up my Windows search bar and I will type CMD to open up command prompt. Okay, so when I try to ping www.google.com, ping is, by the way, a command that you will use to make sure the server that you're trying to reach is reachable. So ping www.google.com. So when you do this and hit enter, you're going to see that it is bringing back the IP address of the Google, the 172.217.12.164. So let's say if you copy this, edit and copy, and now you go to your Firefox and paste that IP address here and hit enter, you're going to see it takes you to Google. See, that's how that DNS comes in because DNS is the one that actually translating google.com to that IP address or that IP address to google.com. When you go back to it, in order to find out who is your DNS server, you could do ns lookup and type again google.com. NSLOOKUP is the command that tells you name server lookup, like what is the name. So it will tell you that I am going to go to my DNS server. In this case, this is my DNS server, which is my router that is in my home. The address of that router is 10.253.1.1. That router is also serving me as a DNS server. So it went to that router, and the router said, sorry, I don't have the answer to find out who google.com is. So I'm going to send you to another server, which is non-authoritative answer that it went out on the internet to the DNS server, to the ISP, and it found the IP address, which is google.com and the IP address 172.217.12.164. So now that's how the DNS functions. Similarly, if we go to our Linux machine, and in the Linux machine, if we do the same thing, ping www.google.com, that ping command works in Linux as well. You will see it is bringing back the IP 172.217.10.100, which is of course different from this IP. It's because Google has not just one server, but many servers that are actually serving their websites. So if you wanted to do this 172.217.10.100, 172.217.10.100, you will see it will bring us back to the Google page as well. Same thing, let's go back, and if I do nslookup, that's the same command that works in Windows as well as in Linux. nslookup.www.google.com, and you will see it went to my router, which is 10.253.1.1, and the router says I don't have that answer. I'm going to go to the DNS server outside through my ISP and I will get you that information. And it comes back and says, hey, I found the record. And the record is www.google.com and it is translating that record to this IP address. And that information is coming from one of those 13 DNS servers that I have talked to you about. That's how the DNS works. And that's how the complete internet works. Hello, everyone. When we are on the topic of networking, one of the things that we should not overlook is the type of networking. There are three different type of networking. One is LAN, MAN, and the third one is WAN. Let's take a look at them one by one. LAN stands for local area network. And it is a private network that connects computers and devices within a limited area like a residence, an office, a building, or a campus. On a small scale, LANs are used to connect personal computers to printers. However, LAN can also extend a few kilometers when used by companies where many computers share a variety of resources like hardware. What are those different type of resource hardware? Printers, scanners, audiovisuals devices, etc. And software like application programs if they are shared, and of course the data. Moving on to the MAN. MAN stands for Metropolitan Area Network, and it is a larger network than LAN. It often covers multiple cities or towns. It is quite expensive and not a lot of organizations own it. Examples of companies using MAN is like a cable TV network, ISP, which stands for Internet Service Provider, or companies running their businesses across country. MAN provides higher speed from 1 gigabit per second to 100 gigabit per second. Now, a lot of companies these that uses MAN technology, please note that they actually have the cable, the physical cable connected from one location to another. All right, then moving on to WAN. WAN stands for Wide Area Network. A wide area network is a much larger network than LAN and MAN. It often covers multiple countries or continents. Satellite is used to manage the WANs. Now, internet is a big example of a WAN. And believe it or not, if you are communicating from New York to London, most likely that communication is having through the WAN when we run and when those cables are actually laid down on the Atlantic Ocean and they go from one country to another. Also, our DNS servers, which are domain name systems, that resolves host name to IP address or a website name to an IP address. Those DNS servers are also run on the WAN network. Hello boys and girls and welcome back. In this video we are going to cover computer storage. Computer storage is a technology consisting of computer components and recording media that are used to retain digital data. It is a core function and fundamental component of computers. It is a piece of hardware as well that is sitting on top of your motherboard as a RAM and a separate hardware device as a hard drive that is attached on your computer, but its cable is connected to your motherboard. So operating system of any computer is installed on the storage. So we know without the operating system, any computer is nothing but a piece of brick. So we have to download and install that operating system somewhere, right? That is why we need the storage to hold that operating system. Storage is needed to store short-term and long-term data. Short-term, we need a RAM, random access memory, and long-term, we need a hard disk drive. All right, so what we will learn is how to identify our computer storage, which is hard disk drive and RAM in Windows and Linux, and storage mapping and partitioning. So I'll go to my Windows machine as well as my Linux machine to see how we could check the computer storage. So first of all, I'll click on Win key on my keyboard and I'm going to type my PC and it comes up as this PC, so that's fine. Right click on it and go to properties. Right here in the properties, you're going to see under the systems, there is installed memory, 32 gig. And that's the short-term memory that I have that is used when I am doing a lot of pages or multitasking. The more memory you have, the better it is for that multitasking. And I'm using, of course, Windows 10 as you could see it right here. If you're using a different Windows computer, different version, you could still go to your search and type my computer and go to properties and you will be able to see this same menu. Now let's go and see our hard disk. How big is the hard disk? For that, I'll go back to my search and type my PC again. And at this time, I will only do a left click, not right click. This will open up all the drives that are attached to my computer. The number one is C drive, is telling me it's 475 gig, and out of which 271 gig is free. The D drive is the ROM drive. That's why when you right click, you'll get the option to eject. So you could put in the CD on it. Then E drive is just my USB dongle that is attached to my computer to the USB port. So when you double click on it, you're going to see the operating system files, your data files, and so on. If you wanted to see how that your entire drive that is inside of your computer that has been partitioned, you could go to your search again and type computer management. Click on it, left click, and go to storage and go to disk management. And right here, click on a Windows C drive. Under the C drive, you'll see the the size of your disk is 476.81 gig. Out of that, 475.63 is entirely given to C drive and it has been partitioned with file system NTFS. Then 260 megabyte is given to EFI systems partition and 950 megabyte is given for system health recovery. If you lose something on your system or if you have to restore, this is where you have to go in and recover your system. All right, so that was about Windows, and let's go to my Linux machine. I will go ahead and log in, and I need to make sure that my Linux machine I'm logged in as a root. So I am logged in as root. So people who are familiar with Linux will exactly know which command I'm running. If you're not familiar with Linux or if you do not have a Linux machine right now, that is perfectly fine. Just watch as I am running certain commands on Linux. So in order to check the disk that is attached to your Linux machine, you will have to run fdisk -l command. And right here, you're going to notice this is the disk that is inside of my computer. By the way, this Linux machine is running on a virtual machine, on a virtual platform, which is Oracle VirtualBox. So right here, you could see it has about 20 gig. Out of that 20 gig, it has two partition. One is for SDA1, or which is the swap, and the other one is for our operating system. So if I wanted to know how much RAM I have in this Linux machine, let's clear the screen and type free, just that. In this free command, you're going to see the memory, which is the total 3881,156. This is in bytes. If I wanted to know in human language, I go to calculator and I'll do 388,1156 divided by 1024. That's 3790 megabyte. Now let's divide it again with 1024 and you're going to notice 3.7 gig. So this is the 3.7 gig, which I'm sure it is close to 4 gig or 4 gig that is assigned to my Linux machine. So if I go to my Oracle VirtualBox portal, so Oracle VirtualBox application. I'm going to open that up and I go to my machine. This is my Linux machine. I go to setting, I go to system, and right here in the system, you notice the base memory is 4096 megabyte, which is 4 gig. By the way, don't get confused if you do not know um, how to check the Oracle VirtualBox, or if you have it, we'll cover that later. So that's how you can check the storage in your computer whether it's running Windows or Linux. I'll see you in the next lecture. Hey friends, in this video we are going to talk about the different type of operating system. Once again, an operating system is a program that controls the execution of applications and acts as an interface between the user of a computer and a computer hardware. In operating system, there is one program that always running, and that's program usually called a kernel, and everything else are the application related programs. Now, what are the different type of operating systems that are out there or that were used previously? The first one is the batch operating system. In this type of system, there is no direct interaction between user and the computer. For example, in this type of OS, every user prepares his or her job on an offline device, like a punch card, and submit it to the computer operator. Now, this type of operating system is not used anymore. Back in the days when there was no direct interaction like a keyboard or mouse to the computer to provide the instructions to operating system, then we used punch card. A punch card had a bunch of holes in it with the instructions for the computer to perform. And the reason it called the batch operating system is because the computer operator would combine those jobs into different batches. Okay, then moving on, the time sharing operating system allows multiple users to share the computer resources. So a lot of computers nowadays, for example, Windows or Linux servers or Mac OS, they are the time sharing operating system where many or multiple users can log into that same computer at the same time and perform different functionality. Then comes in the distributed operating system, manages a group of different computers and make appear to be a single computer. So let's take an example of our e-commerce world. So let's say Google. When there are so many people hitting Google website at the same time, I'm sure there's not just one computer in the back end that's taking all that request. There must be multiple computers working together and taking requests, and there must be some kind of load balancer that is assigning works to these different computers. They work in conjunction to perform certain tasks. These type of tasks are handled by the operating systems, and that operating system is called distributed operating system. Okay, moving on, network operating system. Computers running in different operating system can participate in common network. So, for example, for switches, routers, and firewalls. So, all the devices or network devices that we have, and when we log into those devices to manage, to open ports, to block ports, enable and disable, all that management of those devices are managed by some kind of operating systems that runs on those devices. That operating system is called network operating system. Then the last one is real-time operating system. A real-time operating system is an operating system intended to serve real-time applications that process data as it comes in, typically without buffer delay. Now, this OS is also considered as embedded OS, which is a very small OS designed to perform certain specific tasks. Examples of these type of operating systems are used in like gadgets like smartphones, smart TVs, kiosks, smartwatches, ATM, digital cameras. And you probably notice as soon as you turn on these devices, the operating system comes right up and it performs certain tasks right away in real time without there's any delay. So these are the few operating systems to keep in mind that you're going to be working with. But of course, these operating system is the concepts, but actual operating systems that are built on it are primarily like Windows, Linux, Solaris, Mac OS, and many other. In this video, we will cover the introduction to DevOps. But before we go any further, let's look into what exactly is DevOps. DevOps stands for, or it's in a short form, it's a development and operations. Now, development and operations are two separate teams that can often be found in bigger companies or bigger corporate environments that have, I would say, approximately 200 plus employees who actually build their own software to support their own workflow. And the operation teams are the ones that deploy that software and support that software. All right. So Wikipedia, if you search online and type in what is DevOps, the Wikipedia says it is a methodology in the software development and IT industry. It is used as a set of practices and tools. DevOps integrates and automates the work of software development and IT operations as a mean for improving and shortening the system development lifecycle. It's very simple and straightforward. Now, if you find this definition a bit confusing or hard to understand, then let's make it more simpler. So, DevOps is a collaboration of development and operations team. So that's the very first thing that you need to understand that development and operation teams becoming together as one team. All right. So now what's the purpose? for the improvement of designing, development, and delivery of the application or the software that is being built to support the company's workflow. That's a very simple way to define DevOps. Hey folks, in this lesson, I will provide you with the basic overview of AI, which of course stands for artificial intelligence. So let the excitement begin. Okay, for better clarity, let's first break down the term artificial intelligence. Of course, it is a combination of two words, artificial and intelligence. Artificial refers to anything created by human beings rather than occurring naturally. Before I describe the term intelligence, I want you to take a moment and ask this question to yourself. What do you think of intelligence? Okay, let's check it out. In simple terms, intelligence is the ability to learn, process, and apply knowledge and skills to do your task and solve problems. Just like you take your lessons, create projects, and overcome roadblocks using the knowledge and skills that you learned, right? So, you can simply define artificial intelligence as the creation of machines and systems that are able to learn, process information, apply knowledge and skills to perform actions and solve problems just like humans. AI machines have the ability such as perception, decision making, and adaptation to new situations. Here, perception is the process of analyzing and making sense of the information received through five senses. As per Wikipedia, artificial intelligence is the intelligence of machines or software as opposed to the intelligence of humans or animals. Let's look into it further. AI is a branch of computer science that is about making machines think and act humanly and rationally. Yes, you heard it right. With AI, machines can act and think logically, just like you, me, and all of us, and at some point more efficiently than us. AI made machines can perform tasks like learning, reasoning, problem solving, understanding natural languages, and understanding of the environment as well. These days, AI is helping us in every aspect of our lives. Simple real life examples of AI includes like virtual assistant. Like I'm sure most of you have like Google Assistant. If you have an iPhone, you probably have Siri. If you have Amazon Alexa, that's also like a virtual assistant to you. I will discuss how AI is aiding us and making our lives easier in our upcoming lectures. Now, you might be thinking how AI works. So, in this video, I will tell you the basics, but I promise to provide a detailed lecture on this in a later sections. Okay, let's first understand how humans learn from their experiences. For example, a child learns in the early age that if she screams, the parents will get mad, right? So the child will learn not to scream or try not to scream. Another example would be like an adult who learns that if he comes to work late, most of the time, then he can lose his job, right? That's a learning curve. So these are all examples of learning. So machine learns the same way. For example, if you visit a website that sells shoes, then your internet AI learns that you like shoes and it will show you shoe related websites or ads, right? Another example is your smartphone photo app. It learns to recognize and categorize faces or places by analyzing many images, just like you learn to identify friends in the photo. The app then organizes these images accordingly. Okay, so AI, we all know, uses special computer programs to look at lots of information, recognize patterns, and make decisions. Okay, so now I hope you have a good introduction to AI, and we will discover a lot about it in the upcoming videos. If you want to learn more about Linux, check out my best-selling course on Linux at udemy.com, or you could go straight to my website utclsolutions.com and you will find the exact same course there.